Let's look at how NextREADY gathers evidence for increasing depth of knowledge, specifically within GIS, Geographic Information Systems. But to begin, many people are not familiar with depth of knowledge, so let's look at what's involved. The intensity with which you use a skill or competency is determined by the depth of knowledge that you're using it at. At the most basic level, we're requiring people to recall or reproduce knowledge and skills. That's level 1. At level 2, we advance to use some more mental processing beyond simply that recall or producing a response. And as you can see, the activities change. These are the verbs associated with level 1, whereas these are the verbs associated with level 2. Level 1 and 2 are where instruction and testing take place. But in the real world, employers want strategic thinking, and this is a different set of skills. Here, we're using short-term use of higher-order thinking to solve real-world problems that have predictable outcomes. And at level 4, extended thinking, these are the activities where we're using extended use of higher-order thinking to adjust plans over time. With that said, let's see how we have embedded the same depth of knowledge within the model that ESRI uses for increasing evidence of using depth of knowledge in spatial analysis. ESRI has divided these activities into 6 different groups. Understanding where means understanding location of where things are, or variations in patterns of values from comparative maps, or change, where and when things change. Notice that we still have the same depth of knowledge in here to be able to say what we're doing, where we're working at these 4 different levels. When we move to measuring, we're looking at size, shape, and distribution. That means calculating individual feature geometries or calculating distributions of feature collections. The ESRI model continues in determining how places are related. Their proximity, what's nearby, can we summarize what's within an area, what is closest, what can we see from a given location, and how are the overlapping relationships taking place in space and time. When we look at finding best locations and paths, we look at criteria, resources, a network path or flow along a path, or a flow along an open path, and where would we put supply locations given these things? As you can see, we're getting quite detailed in the amount of analysis we're able to do. And when it comes to detecting and quantifying patterns, we look for hotspots, trends, similarities, and changes. And the highest level of all is using all of this to make predictions. Can we replicate a success? Can we understand the factors that explain the patterns? Can we interpolate? Can we see how things interact spatially? When we're looking at radio and other things like that, can we predict how and where objects will affect wave propagation? How will phenomena move, flow, or spread? And ultimately, can we predict what if? When you take this what if in terms of extended thinking, you will have gathered information that gives evidence of the highest possible thinking that you could be doing. And that's what we're doing within our work with ESRI, GIS, and NextREADY. We also go back to the Geospatial Technology Competency Model, which the Department of Labor has done. And you can examine how we are able to measure, whether it's at a core level or a different level, key knowledge areas including analytical methods, cartography and visualization, conceptual foundations. It's all here, and that's what we're going to be doing with students and teachers as they enter computer science through the entryway of GIS. Thanks a lot.